Welcome back to the Deep Dive, your shortcut to being genuinely well-informed. Today, we're peeling back the curtain on something you definitely see at every airport, but maybe don't think twice about. Aircraft towing and pushback vehicles.
That's right.
I mean, these machines, they don't fly, obviously, but as we're about to find out, they play this absolute crucial role, keeping flights safe, efficient, on time, all the good stuff.
Exactly. And our source material for this deep dive is a really handy quick guide focusing just on these vehicles. So our mission really is to pull out the most important nuggets of knowledge, the key insights, give you a real leg up on understanding this often overlooked bit of aviation, and maybe throw in a few surprising facts along the way.
Okay, let's unpack this right from the start then. The big question.
Yeah.
Why? Why do aircraft, these massive machines with incredibly powerful engines, why do they even need a pushback? Can't they just, reverse themselves out?
Yeah, it's a question that makes a lot of sense on the surface, doesn't it? But the simple truth is, aircraft really can't safely move backward on their own power from the gate.
Okay.
Those engines are built for massive forward thrust. Using reverse thrust right there on the ramp is just inherently dangerous.
Oh, so.
Well, you've got the risk of jet blast, first off. That's the incredibly powerful air shooting out the back. And then there's FOD, foreign object damage.
Right, FOD, heard of that. Like debris.
Exactly. Loose stuff on the tarmac, maybe gravel, maybe a tool someone dropped, gets sucked into an engine. That can be, well, potentially catastrophic. So that's precisely why these specialized pushback tractors, or tugs as they're often called, step in. They handle the pushbacks safely.
Yeah.
Precisely.
Okay,
Yeah,
that makes perfect sense. When you think about the sheer force involved, yeah, pointing those engines away from the terminal and everything else is definitely a good idea. Now, when I picture a tug, I sort of have one image in my mind. But you mentioned variety. Here's where it gets really interesting, I guess.
You're right, it does. Our source highlights a few main types, each designed for different needs, different aircraft. So first up, you have the conventional tugs. These are probably what you're picturing.
Was it the long bar?
Exactly. They attach to the aircraft's nose landing gear using that metal bar, the tow bar. They're very common, widely used, generally cost-effective. But there's catch.
Oh.
You need a different tow bar for different aircraft types. It's definitely not a one-size-fits-all kind of deal.
So if an airport handles, say, a 737 and A320, maybe some smaller regional jets, they need a whole collection of these tow bars ready to go.
That's exactly it. It can be a bit of a logistical puzzle.
Yeah, sounds like a potential bottleneck. Is there an alternative? Something to avoid juggling all those bars?
There is. And that brings us to towbarless tugs. As the name suggests, no tow bar needed. Instead, they have this clever mechanism that clamps directly onto the aircraft's nose wheel.
Oh, interesting.
Yeah, and this offers some pretty significant advantages. They're generally faster, more efficient, especially for quick turnarounds. You save the time fiddling with the tow bar. But here's something really insightful from the guide. They also reduce wear and tear on the aircraft's landing gear.
Less stress on the gear itself.
Precisely. And landing gear overhauls, they are incredibly expensive. We're talking millions. So anything that extends the life or reduces stress during ground ops, well, that translates to potentially huge long-term savings for the airlines.
Wow, okay. So it's not just about speed. It's a serious financial benefit, too. That makes the towbarless design sound like a much smarter approach, generally.
For many operations, yes.
But what about the real giants? The big wide bodies like the Boeing 777s or those massive Airbus A380s? Do they use the same kind of tugs?
Good question. For those heavyweights, you need something more robust. That's where specialized pushback tractors come in. These are just heavier, much more powerful machines. They're purpose-built to handle the immense weight and inertia of those wide-body aircraft.
Right, more power needed.
Definitely. And what's quite fascinating here, and a nod to the future, is that many of these newer specialized tugs are featuring electric or hybrid technology.
Going green on the ground, too.
Exactly. It's a big push towards more sustainable ground operations, cutting down emissions, reducing noise pollution at airports. It aligns with that whole industry trend.
That's great to hear. So, okay, we've got the different types of vehicles covered. Conventional, towbarless, specialized. But knowing the tools is one thing. It's still sometimes hard to picture that coordinated dance you see from the window seat. Can you walk us through the actual sequence? What happens step by step on the tarmac when a plane's getting ready to push back?
Yeah, absolutely. It's a very precise sequence, like you said, almost like a little ballet. Safety and efficiency depend on it. Our source breaks it down into about 6 key steps. First, and this is non-negotiable, clear communication. The ground crew uses a headset to talk directly with the cockpit.
Right, that connection is vital.
Absolutely critical. Second, the tug gets into position right in front of the aircraft and connects to the nose gear, either, hooking up the tow bar or clamping on if it's towbarless.
Okay, so connection made, communication established. What's next? Does the pilot just, give it the go-ahead?
Pretty much. Once the ground crew confirms everything's secure, the connection is solid, the path behind is clear, they instruct the pilot, and the pilot then releases the aircraft's brakes. That's step 3.
Breaks off.
Brakes off.
Right.
Then step 4, the tug starts to gently push the aircraft back from the gate. And it's a gentle push, slow, controlled, maybe just a few miles per hour.
Not racing away.
Definitely not. Once the aircraft is clear of the gate area, clear of any obstacles, the tug performs step 5, aligning the aircraft properly onto the taxi line, that painted line on the tarmac.
Getting it pointed in the right direction.
Exactly. And the final step, step 6, is crucial for safety. The pilot confirms the aircraft brakes are set on again. Only then, once that confirmation is received, does the tug disconnect and move safely away. The aircraft is then ready to start its engines and taxi.
Wow. It really is a precise choreography. 6 steps, perfectly executed every time, hopefully. Which brings us naturally to the most crucial element here, safety. With all these moving parts, you've got huge aircraft, powerful machinery, often in pretty tight spaces. What measures are really in place to make sure it all goes smoothly and, most importantly, safely?
Safety is absolutely paramount. It underpins everything in this operation. The guide highlights several critical things. First, as we touched on, the strict communication protocols between the pilot and ground crew. Clear, standardized language, no room for ambiguity.
Got it. Clear comms.
Second, you'll almost always see other ground crew members involved, not just the tug driver. These are the marshalers and the wing walkers.
Ah, yes, the people guiding with the luminous wands or walking alongside.
Exactly. They act as extra eyes and ears for the pilot and the tug operator, checking clearances, watching wingtips, guiding the aircraft visually, especially with the pilot's blind spots. It's a team effort.
So it's not just one-on-one pilot to tug. It's a whole ground team coordinating.
Precisely. And then there's the equipment itself. Regular, thorough maintenance of the tugs is vital. You can't have a breakdown mid-pushback.
Oh yeah, that would be messy.
Messy is an understatement. It's not just a delay for that one flight. It could gridlock a whole section of the airport, cause massive ripple effects. So preventing breakdowns is key. And finally, something else to consider is the weather.
Right. Rain, ice.
Yeah, heavy rain, snow, ice, even just low visibility like fog, they can significantly impact pushback operations. They affect traction for the tug, visibility for everyone involved, even how the equipment responds. It adds another layer of complexity, requires even more caution.
It's clear this seemingly simple task, just moving a plane back a few hundred feet, is actually incredibly complex, requires huge coordination, constant vigilance. So looking ahead now, what's on the horizon for these essential ground vehicles? What kind of advancements can we expect in the future of aircraft towing?
This is where it gets really exciting, actually. It shows how innovation touches every part of aviation, not just the flying bits. We already mentioned the big push towards electric tow tractors. That's happening now, aiming for greener airports, less noise, fewer emissions on the ground.
Makes sense. What else?
Well, a really major development being explored and tested is autonomous pushback systems.
Autonomous tugs, like driverless.
Potentially, yes. The goal is to leverage automation, advanced sensors, AI, to reduce the potential for human error and maybe increase efficiency. The big challenge, of course, is the airport ramp environment. It's incredibly dynamic, unpredictable, lots of moving vehicles, people, unexpected obstacles. Programming a machine to navigate that safely 100% of the time is, it's a significant technical hurdle they're working on.
I can imagine. That sounds complex.
It is. And alongside autonomy, we're seeing the rise of smart monitoring tools for the tugs themselves. Think sensors tracking engine health, battery life, hydraulic pressure in real time. This allows for predictive maintenance.
Ah, so fixing problems before they happen.
Exactly. The system flags a potential issue before it causes a breakdown, rather than just reacting afterwards. That means more reliable equipment, fewer unexpected delays. It's all about improving that operational flow.
Autonomous tugs, predictive maintenance. That's a pretty bold vision for the future of the tarmac. It's amazing, really. So easy to just glance past these machines. But it's clear they're not just simple tractors. They're involved in some really cutting-edge tech, just like the planes they push. So maybe the next time you're sitting on a plane, waiting for that gentle pushback from the gate, take a second look at that big vehicle out front. Remember, it's doing more than just moving the aircraft. It's a key part of ensuring safety, efficiency, and a smooth start to your journey, all orchestrated by a skilled team and some pretty smart engineering.
Absolutely. And it's just fascinating to consider, isn't it? How this seemingly small, almost mundane part of the whole air travel process, something many of us barely notice, is constantly evolving. Driven by technology, electric power, autonomy on the horizon, smart systems, all aiming for even greater precision, greater safety in this incredibly complex, coordinated dance that is modern aviation. It really highlights how every single component, no matter how grounded it seems, plays a vital role in the bigger picture of getting you safely and efficiently to your destination, and how that pursuit of improvement touches absolutely everything, even the pushback.